Right, so I'll just go through a quick recap first, because it has been quite a long time. Well, 1 week, that's quite a long time to retain information. So first thing we should go through is printing. So obviously everyone probably remembers how to print. Simply print, comma, etc., etc. And then move on to variables. There are 4 variables. There is 1, which equals, let's say 1, 2, 3. That's an integer, so that's just a random number you can put in anywhere. It treats it as a number, etc. Doing using all your mathematical operations on it. Variable 2 will do 23.4. So this is a float, which is the decimal numbers. Anything with a decimal point is treated as a float. Variable 3 will do a string. So hello, that's just a text encased in quotation marks. And the final variable, which we will be going through more today, is the Boolean variable, which is true or false. Yep, so those are the 4 variable types. Just go quickly over the naming conventions of variables. Variables can be single words only, and they can't be keywords. So variable with a space between it technically isn't a actual viable name for a variable. If you want to use spaces, you have to use an underscore in order to name it. Okay, that's variables. Operations on variables. So variable 5, that's just the pluses, the minuses, the multiplications and divides. So variable 5 equals like 45 times 45. Asterisk is for multiplication. Plus is for addition, and minus is a minus sign, and divide is just a backslash. So variable, sorry, /5 divided by variable 4. Make sure it runs. Yep, so those are the simple operations. As you can see, you can, there we go. Yeah, sorry, I've done the wrong one. I've named it variable 4 instead of, put the space there. I was like, the naming convention is wrong. Division by 0. Sorry, variable, what am I doing? Sorry, variable 4 is, this is a good going into casting, I guess, try and sort this out. Variable 4, obviously you can't interact with an integer and a bool. So I'll just do variable 2, sorry about that. There we go. And what we do next, casting values. So casting, you can go from, casting is moving from one data type to another data type. So let's just work with the hello. Let's change hello to 23. So if you wanted to change that value of 23 to an integer, we do variable int and then variable 3. That's just casting, so it's now treating that as an integer. So anything that's inside this bracket is treated as an integer. And then of course there is float. So variable 8 equals float brackets, and we'll change that to 23.6, and it will treat, sorry, 20.6 variable 3, and that will change that to a float. And then final one, actually we won't do that because we won't actually need to use it. Yeah, there's that. And the final thing is probably going to be on the questions and the examples. There'll be like comments which start with a hashtag, and these are, you know, not run when you actually run the program. It's just there for your own notation so that you can better understand your code when you come back to it, or if I like comment it to give example. Okay, as I think last week's stuff was quite straightforward overall, I probably won't go any more through a recap, but we should move on now onto Boolean variables. I have misspelled that and I thought I'd changed it. My bad. So for Boolean variables, as we said last time and in the recap, is that are variables that can either be true or false only. They can have no other value. Therefore, they're often used like when testing facts and variables and like conditionals. We'll go through what conditionals do next lesson, but just remember this is really, really important, and basically the basis of most programming is decision making, and you need these conditionals of true or false to actually make like conditional arguments like work. So I'll just quickly start with, let's start with variable 4 equals the value 4, and then we'll just do variable 5 equals the value 5. Now, there's something called comparison operators. So you'll have come across this in mathematics, like really early on. So that's like the greater than symbol, or smaller than symbol, or the equal to symbol, etc. All of those things. So I'm going to quickly go over that. This is simply what that is. So for instance, variable 6 equals 5 greater than 4. So what this is doing is it's checking if 5 is greater than 4, and then it's returning whether or not that statement is true. So in this case, I'll just print out the result of it, variable 6, true. So what's happening here is it's going 5 is greater than 4, and it's saying this is a true statement. So it's replacing the whole of this with true. And then when I print it, it comes out with variable 6. But if I change it the other way around and I go 5 is greater than 5, or obviously it's 5 greater than 4, obviously it's going to replace that with false, because 5 is not greater than 4. So if I run that, false, it comes out as false. So all it's doing is comparing the two, the left and the right side, and then the result of that, true or false, is assigned to the variable, and that's what we printed. There's another thing that you can do with comparisons, and that's called equals to. This is represented by 2 equal signs. So 5 equals 4. So when I run this, it will come out as false. What this is simply doing is it's checking if 5 is equal to 4. And if it's not equal to 4, then it says false. So in this case, always it's false because 5 is not equal to 4. But you can do this with variables, which is like where it's more useful. Say we don't actually know what's in the variable. So like we don't know what's in variable 4, we don't know what's in variable 5. It will check and compare variable 4 to variable 5. So what it's doing is going to variable 4, finding variable 4, assigning that there. It's going here, it's going is equal to, and then variable 5, which it's replacing with 5. So what it's checking is 4 equals 5, and then obviously that's false. Or if I change this to 4, so both of the values are 4, it will come back as true. Now the opposite of this is the symbol is not equal to. This can be like written by getting rid of one of the equal signs and putting an exclamation mark. So this is basically the complete opposite of is equal to. So this will be true. Oh, sorry, false. So what it's doing is variable 4 not equal to variable 5. And in this case, 4 and 4, so they're equal, so it's saying false. But if I change that to 5 and run it, that'll come back as true, because variable 4 is 4 and variable 5 is 5. So it's gone 5 is not equal to 4, and it said that is true, and therefore it has what's it called? Continued. It has printed for true at the end. Now, so there's a final 2 symbols, and that's greater than or equal to, or greater than or equal to, or greater less than or equal to. So this is exactly the same as is greater than and less than, except it includes the number itself. So is 4 greater than or equal to 5? Obviously that's false, but if we were to change that to 4, it'll come back as true, because it's just less than or equal to. The same applies to less than or equal to and more greater than or equal to. Where we can use this is, I'll go more into detail later on, because this is extremely important. I'm just bringing it up now so that everyone's familiar with it next lesson. You can also test if strings are the same. So if I had, so string test, and let's just do the words, I can do, I can test if that actually is what's inside the variable. So I could do words, I could do word equals to string test. So what it's doing here is it's testing if word is the same as what's held in the string test variable. It's printing out the result, which is false. But if I were to put words equals string test, true, because it's testing what's inside the string test variable, and it is words, so they're both the same. So you can test strings as well as numbers. On top of that, you can also compare Booleans themselves. So let's say true, another one's true. You can test if they're both true. So you can do variable 4 equals variable 5, and it will test true, and then if I do does not equal to, it will come back as false. So you can also test Boolean variables themselves. So is true not equal to true, but it is, so it's false. Okay, now moving on to strings. So we've come across strings already, but we haven't really done much with editing them. We've just sort of done printing them out and storing them in variables. So strings have loads of inbuilt functionality, which allows us to edit and gather data from them. So this allows us to sort of basically grab sort of numbers or letters out of the string and sort of do things with them, or we can take like large parts of the string and take them out. So for instance, if we wanted to take the word campus out, we could do that. Or if we wanted to just take the one letter, like the letter D out or the letter A out, we could do that just to sort of just get values out of the string. So the way we do this is using what are called indexes. We can think of like a string as ultimately a set of individual like symbols or letters. So its first letter is a I, and then the second letter is a blank space, and its third letter is a W. So what we can do is we can sort of access each single individual letter by its index, which is just its place in the string. So for instance, if we wanted to print out let's say we wanted to print out the first letter in the string. So sentence, okay, 0. If I print that out, I've spelled sentence wrong. There we go. I. So we've printed out the first letter in the string. So when we try and get a specific letter from a string, we start counting at 0. So what this means is the first letter is represented as the 0 value of the string. The first letter is, sorry, and the second letter is represented as the first value. So if I type in 1, it will actually just return a space bar, a space. And if I were to do the second letter, or the second letter here, it actually refers to the third letter. So it will print out the third letter, which is that, etc., etc. Obviously, the fourth one will actually return the fifth letter. So that's the first, that's 0 value, 0 value, first value, second value, third value, fourth value. So it starts at 0, and then from there, each letter is represented by a higher number. So it sort of just works its way up. So you can sort of think of a string as basically a set of single symbols, one after the other, that can be accessed by their like index, like the identity. So you can obviously just pick whichever number you want out of it. You can also use negative numbers in this. So I could use -1 as its index, and that will give you the last letter. So if you put a negative, it counts all the way from the back. So -1 will be the last letter, and -2 will be the U, which is the second last letter, and then -3 will be the third last letter. This is just these are called indexes, and they're just pulling stuff out of the string. Okay, slicing. Now, you might not just want to pull one letter out of a string. You might want to like pull out a whole section. So this is possible as well with something called slicing. This once again uses the indexes of like the string. So if I print, I do sentence, and let's say I want to get the words I walked. So I'll put where the first index of where I want to slice out. So 0, so that's the first letter, followed by where I want to slice up to. So in this case, I want to do I walked, so that's the first, the second, the second, the third, the fourth, the fifth, the sixth, the seventh. So if I were to do 7th, let's do 8th. Okay, so I've printed out I walked. So what this is doing is it's taking the first one, which is 0, and then it's going all the way to the 8th one, and it's going back 1 and cutting it. So what it is it's going from the 0 index to the 8th index, not including the 8th index. So 0 to 7 in this case, as opposed to 0 to 8. So it's up until the second number, but not including the second number. As it was number 4, you can also use negative numbers in this as well. So I will do the word campus. So I will do -1 at the end, and I want it to end at C. So -2, -3, -4, -5, -6. So that should be there. Oh, sorry. So what if you're completely forgotten about this, if you want to include the last value at the end, you have to leave it blank. Because as I said, it's up until and not including the last number. So if I were to put -1 in, it would go all the way from -6 up until -1, but not including it. So if you want to include the end of it, you want to use nothing at the end. You just want to leave it blank. The same applies for the start. You can leave that blank as well. So if I wanted to do exactly the same, I've left it blank at the start. So it goes from right at the start of the string to the 8th value. So those two are literally the exact same. So you can also use this to actually assign the sentence to a variable. So instead of just printing out I walked, I could assign that to a variable. So send sentence2 equals sentence that, and then I could just do print and sentence2. And when I print sentence2 out, it will have been assigned the first like 9 or 8 letters of the string. So you can cut strings up and to what like length you want them to be, and then assign them to another variable. Okay. Right, now the reason indexes are really important, the place you'll probably use them the most is actually in something called lists. So if we go back to a string, like the one up here, I said that basically it's just a collection of symbols, one after the other with their own index. Now this the same thing applies to a list. So lists are a way of gathering lots of variables into like an ordered set. So let's say you have a catalog with loads and loads of prices, but you don't want to have to create a variable for every single price value. All you want is one massive entity which has all of your values in it. So this is where a string comes in useful, because you can assign lots and lots and lots of values to, or variables in this case, to a like one ordered list of things. So it's kind of exactly like a string in that sense. So instead of having one letter with its own index, it's a whole variable with its own index. So I'll just show you how this is done and show you how it works. So test list, no, actually I'll do test1 equals, and we'll make a list. This is how you make a list. You open it up with square brackets, and then you put your values in there. So I'll just quickly do that. 1, 2, 3, 4, 5. What this is doing is it's creating a list, and it's creating a value, creating a list, and it's putting in values of values for a variable, basically. So what it's doing is it's assigning the first entity in the list the value 1, the second entity in the list the value 2, the third entity the third 3, and the fourth, and the fifth, etc. So this is exactly the same how strings work, where it's basically just symbols represented by an index. So just in the same way that we'd access a string with its individual values, we can access a list. So let's just print and then just do test1 in the exact same way you were doing it with strings. You use a square brackets and then put the value in. So if I print that out, it'll give you the first value, because once again, the indexes start at 0. And to get the second value out of that string, you'd have to put 1 in, as you see, like that, and then 2. All the things that apply to a string apply to a list as well, except this time lists can hold like full values as opposed to just a single value. So as I said, it just holds values. It can also hold like any kind of value. So it could hold 34.5. It could hold 35, 25, an integer. So a float, an integer. It can also hold a string, like the word, and it can also hold a Boolean. So a string can hold any kind of value that you'd like, and it just stores it in an ordered way. So you can access those by 0, 1, 2, 3. On top of that, you can sort of add to the lists as it progresses. So you could do test2 dot append, and then I'll just quickly write this out. 43. Let me just make sure I've written that right. Yes. So what this does is it adds to the end of the list. So if I print out the list here, test_2. This is printing out the list, is added the value 43 to the end of this list. So what I've done here is I've had a list and I've done list name. So in this case, it's the variable name test2, and you've done dot append and then bracket 43. And it's added the value 43 to the end of the list. So I can do the exact same as, you can do that as many times as you like, any kind of variable, and I'll just print that out as well. Test. And you see hello's also been added after 43. So I've created the original list, and I've added 43 to it, and I've added hello to it. And these can be looped through and interacted with as the original elements that were added to the list. On top of that, you can also overwrite things in the list. So say a value changes at some point and you want to overwrite it to be used later, you can do test2 and find the index of the value you want to get rid of. So in this case, I want to get rid of the first value, which is 34.5, and I can assign it another value. So I want to replace 34.5 with just 345. Actually, that's probably just make it more obvious, 4,000. So originally, as you can see here, it's 34.5 is the first value, but now I'm overwriting it. So what I'm doing is I'm saying, okay, this is the first value in the list, and I want to assign this to it. So what's happening is it's got 4,000 and it's adding it to the left of the equal symbol. So it's literally just going into the list, finding the first value and assigning 4,000 to it and overwriting it. So from now on, the first value is not going to hold 34.5, but instead hold 4,000. Okay. Now, if you also want to delete something from a list as well, so say I by accident put the word in, and I actually just want to get rid of it now, I can do that by using the keyword delete. So if I just use the words del, which is delete, and put test2, and then I want to get rid of word, and the word's the third one, so I'll put its second index in. And then if I print this out, as you can see now, word is no longer inside the list, and the list has been crunched up. So what I've done is I've done del, and then I found I've said delete the second index in the list, which in this case is word. And so then ultimately what it's done is it's just deleted word, and then just shoved everything left one, because there's a free space, so it shoved everything left. So now true, which was previously the last one, is now, well, continuing still is the last one, but was in the third index, because 0, 1, 2, 3 is now shifted to be in the second index. Yeah, so there's that. What else are there? So that's probably all you need to know for strings. There's the lists. Those are the main things that you'll basically need to interact with them. At some point, you might come across like an issue, or not an issue, a problem where you need like really like nice functionality for lists in order to sort of interact with things. Honestly, if that happens, then just Google it, because there's so many things that are built into all these like things in Python that not everyone's going to remember them. I personally don't remember all the functionality. It's just that del and append are obviously used quite often. So yeah, so that's why I've introduced them and not many more, because otherwise I'll be just throwing loads and loads of functionality at you that you'd never ever use. But there are many other sort of functionalities that you can use alongside lists that are built into Python. Now, lists are great. They hold loads of data, but you honestly want to be able to do something with that data and sort of interact with it and all of it without having to just write everything individually. So I'll just give an example of this. If I just do a test list, I'll just call it test list 1, and I'll assign it 1, 2, 3, and then 6, 7, 8. Now, say I wanted to double everything in that list or add like 0.5 to it. I don't want to have to go test list 1, get the first value, and just go equals 2. I don't want to do that, so that would change the first value to 2. I don't want to have to just go through every single one and double it like this and just writing every index out as I can, because that will take absolutely ages and it will be really tiresome and just really boring. So there's a way of sort of going through every single value in a list, and this is done by using something called a for loop. So I'll quickly introduce that now. Okay, what this means is we are looping through every single member in that list. So for every number, this can be everything. This is just like a temporary variable that holds something. So this can be anything. This could be just the letter I, the letter J, or test variable number. What's here doesn't really matter. But so it's for number in test list. So what this is doing is it's saying for every value in your list, and then it goes into the for loop. I'm quickly going to write something out here and I'll explain it. So I will do number print number times 2. I'll quickly run this. So what this is doing is it's, as you can see, I've printed out all the numbers in the list and I've multiplied them by 2. So how this works is it starts right at the beginning underneath this statement, and it says what it does is first thing it does is it assigns the first value of the list to number. So this is just like a temporary variable, and then it runs this code here. It goes print number times 2. So number is replaced by 1. So the first time this loop runs, it will be print 1 times 2. Now, once the loop is finished, it will go right back to the start of the loop, and it will replace number with 2, which is the second one in the list. So then when it goes back down here, it will go print number times 2. And this time number is replaced by 2, so it's 2 times 2. So I'll print out 4, as you can see here. Then once that's done, it will go right back to the beginning of the loop, and it'll say for number, and number will be replaced by 3, which is the third one. And it will go back down here, and it will go print number, which is 3 times 2, which will be 6. So ultimately what it's doing is it's constantly repeating this part here, but each time it's replacing number by the next thing in the list. So you can do multiple things on the list. So all I've done here is I've looped through it and I've just printed them out. But we can also do multiple things in a loop. So I'll print something else out like the next value. And we print that out. It'll be 2 the next value, 2 the next value, 4 the next value, 6 the next value, 12 the next value. So once again, what this is doing is it's creating a for loop. And first run through is assigning 1 to the number, and then the second one is running 2, 3, 6, 7, 8. But this time it's also doing that, but then it's also printing this out. So it will loop, assign 1 here, do all of those 2 statements here, then go back to the beginning, then assign 3 to it, and then do both of those, then assign 6 to it, and then do both of those statements. So it's a for loop cannot just be like one statement or one command. It could be loads of them. And the way that you know how many commands you're looping through is by having an indent. So you might not have noticed, but once I did for number in test list and then added a colon there, everything afterwards is slightly indented. So this indent is created using the tab key. So if I click tab, pushes it forward. And what it does is it loops through everything that's indented below it. So let's say I unindented print the next value when I ran it. 2, 4, 6, 12, 14, and then it prints the next value at the end. So what it's done here is it's looped through that statement 6 times, since there are 6 values in the list, each time assigning the value. And then it notices that it's no longer indented here. So then it gets out of the for loop and then runs the program like normal. So it prints out the next value. But if I indent that, it will run it and it will recognize that it's in the loop and not out of the loop. So it will run it every single time. So once again, assign the number, multiply it, do the whole loop, and then assign the second number, do the whole loop, assign the third number, do the whole loop, assign the 6th number, do the whole loop. So that's simply the basics of what a for loop is that it assigns, it loops through the list and it assigns every single value to the to what you put here. So as I said, it can be basically like any variable name that you just want to use. It could just be like I, so I just use print I times 2, and then it just does that. So it just loops through. So I can just once said and just do print all values completed, and that will run once as opposed to all 6 times, which these are running because it's no longer indented with a tab. Yeah. Okay, another thing to state. Another thing you can do is you can interact with things that are outside of a loop. So if I were to do total value is equals 0, stuff with that. I can also sort of, so I can print out the everything multiplied by 2, as I showed, but you can also sort of add things together that are out from the loop. So in this case, I'm going to do total value equals, and then I'm going to do total value plus I. Okay, so total value, what I want to do is I want to add everything in this string, in this list together. So the way this works is that I'm going through the loop again, as you can tell, 6 times I'm going through it because there are 6 values, and each time I'm adding the first value, the second value, the third value, each time I go through it. And what I'm doing is I'm doing total value, which is originally 0 and set outside the loop, and I'm adding I to it every single time. So it starts off with 0. 0 equals 0 plus I. So the first value in the loop is 1, so it will add 1 to it, and then it will start the loop again. And since it was 0 plus 1, total value is now 1. So the next time I go through the loop, total value is 1. And then I'm doing total value equals 1 plus I, and this time I is set to 2 because it's the second loop. So now total value is now 3. And then we go through the third time. I is set to 3. And then so it's then 3 equals 3 plus I, which this time is 3. So now total value is 6, and if we run through it the 4th time, I is assigned 4, and we, it's assigned 6, and then we do total value equals total value plus 6. So you can also sort of interact with things that are outside the loop if you want to sort of add things up, etc. But one thing you have to realize is that once you exit the loop by getting rid of the tab and going back to the start, just by using tab key on your computer, anything that's created inside that loop no longer exists. So if I try to print out I, for instance, which is, temporarily represents each value in the list when we loop through it, is sort of no longer no longer sort of exists outside the loop. So I is just a temporary value that we don't know about, we can't interact with. So the second we leave that loop, I no longer exists. Okay, that's probably a lot, and I feel like you probably need to go through some exercises with it to fully understand it, because for loops and lists are quite complicated. So that's probably it for today. Thank you once again to my TAs, the Entrepreneur Society and the AI Society, for allowing ExCode to happen. So your TAs should have posted a link to their Zoom call as well as to the Colab files. So thank you very much. I understand that was a bit of a rocky lesson, but I hope you learned something. If not, well, I hope your TAs can cover it for you. Also, I will be doing a recording of myself going through the answers to the exercise. I'll release this probably in 2 days or so. So if you don't get the chance to complete all of them or whatnot, you'll have a way to sort of answer them for yourselves. Okay, thank you very much. That will probably be it.